Hello everyone. Today we'll do a problem related to Gram-Schmidt orthogonalization procedure. Given four signals S1t, S2t, S3t and S4t, which is shown in this particular figure. So we can say that S1t has a duration of 0 to t by 3, S2t has a duration 0 to 2t by 3, S3t from t by 3 to t instead of 2t by 3, and S4t from 0 to t. Using Gram-Schmidt orthogonalization procedure, find the orthonormal basis functions for the set of signals. A small correction, S3t ranges from t by 3 to t instead of t by 3 to 2t by 3. For doing this problem, let's have a quick recap on Gram-Schmidt orthogonalization procedure. We know that if we have m signals, say S1t, S2t, etc., SMT, and we have an n-dimensional space. Yes, I got. Now we can represent these m signals in this n-dimensional space. So as a result, any signal, say SIT, can be written as a linear combination of n orthonormal basis function. Let's assume that let phi1t, phi2t, etc., phi-nt be the n orthonormal basis function. Then any signal can be written as a linear combination of this n orthonormal basis function. So we can write it as S1, SIT can be written as Si1 phi1t plus Si2 phi2t plus etc. plus Sin phi-nt. Any signal can be written as a linear combination of n orthonormal basis function. That is, say SIT equal to Si1 phi1t plus Si2 phi2t plus etc. plus Sin phi-nt. Now the present situation is we don't know the orthonormal basis function corresponding to the n-dimensional space. We have given only m signals and we need to derive the n orthonormal basis function from the given set of signals. This is done with the help of Gram-Schmidt orthogonalization procedure. So now we have m signals, say S1t, S2t, etc., SMT. And from this given m signal, we can derive the n orthonormal basis function. So for that, we will use Gram-Schmidt orthogonalization procedure. So the step number 1 will be, so as discussed in our class, we have a, let's have a quick recap. Step number 1 is, choose any signal. Say for the sake of convenience, I am choosing say S1t. From S1t, we can find phi1t. So we have phi1t can be written as S1t divided by norm of S1t. So we know that norm of S1t equal to square root of energy. That is square root of E1. So now we have S1t divided by root of E1. So S1t can be written as, say, root E1 phi 1t. So which is equivalent to root E1 S11 phi 1t. What is S11? S11 is the square root of energy. Now similarly, now step number 2 is we need to find phi 2t. Now what is phi 2t? Phi 2t will be equal to, so for finding phi 2t, so we from the n-dimensional space we know only phi 1t. Now what we will do is we will derive the phi 2t from the second signal S2t. You can choose any other signal also, but for the sake of convenience I am choosing S2t. So from S2t we need to remove all the components related to the first axis. We have here the first axis is phi 1t. Now what will remain is I will write it as G2t. So I will consider G2t as an intermediate function. intermediate function orthogonal to 5 1t. So I will repeat once again. So from S2t we will find G2t. Now what is G2t? G2t is an intermediate function which is orthogonal to the first axis. First axis is 5 1t. Now how will you find the component corresponding to component orthogonal to 5 1t? You remove all the components related to the first axis from S2t. That is, I will write it as G2t equal to, our signal is S2t. You remove all the components related to the first axis from the signal S2t. That is S2t minus S21 5 1t. So in the case of Euclidean space, say for example, say P equal to vector P equal to 3i plus 4j. We need to find j. Now we can say that 4j is orthogonal to this P minus 3i. So we can say 4j is the intermediate function. So here what is 3? 3 is the projection of the vector P on first axis. Similarly, in this case, what is S21? S21 is the projection of S2t on 5 1t. Okay, so we can say that G2t is a component which is completely orthogonal to the first axis. Okay, now how will you find phi 2t? Now phi 2t will be equal to G2t divided by norm of G2t. Now what is G2t? What is norm of G2t? We know that norm of G2t is the energy present in G2t. That is, norm of G2t can be written as root of energy. We need to take integral, right? Integral 0 to t. Now what is G2t? G2t is S2t minus S21 5 1t square dt. So I will try to expand. This will be equal to integral 0 to t S2 square t dt minus 2 into integral 0 to t S21 5 1t into S2t dt plus integral 0 to t S21 square 5 1 square t dt. So as we discussed in our class, this will be equal to integral 0 to t S2 square t dt is E2, energy of the signal S2t, minus 2 into, we know that S21 is a constant, 2 into S21 into integral 0 to t S2t 5 1t dt. What is S2t 5 1t? This is the projection of S2t on 5 1t axis. So I will write this as S21 plus S21 square is constant, that is S21 square into integral 0 to t 5 1 square t dt. So we know that this is 1. Why? Since 5 1t is an orthonormal basis function. Orthonormal basis function means its energy is 1. So this will be equal to root of E2 minus 2S21 into S21, that is 2S21 square plus S21 square, that is S21 square. So this is norm of G2t. So far we found phi 1t and phi 2t. Phi 1t from S1t and phi 2t from S2t. Now step number 3. We need to find phi 3t from S3t. So for that, we need to define an intermediate function, say G3t. What is G3t? G3t is a component which is completely orthogonal to the first and second axis. First axis is phi 1t and second axis is phi 2t. So how will you find that orthogonal component? That will be removed from this S3t. That is S3t minus, we need to take the projection of S3t on phi 1t axis. That is S31 phi 1t minus S32 phi 2t. Now, what is phi 3t? Phi 3t is G3t divided by norm of G3t. Norm of G3t is simply the energy of G3t. So as we discussed earlier, how will you find the norm of G3t? Norm of G3t will be equal to, based on the previous expression, we can generalize it as, say, E3 minus S31 square minus S32 square. So similarly, in this way we can proceed to find other orthonormal basis function. Generally, we need to find, say, phi it. How will you find phi it? We will define an intermediate function git such that git will be equal to, for finding the git we need to take SIT, right? So from SIT you remove all the components corresponding to other I minus 1 axis. So that will be equal to SIT minus SI1 phi 1t minus SI2 phi 2t etc. minus SI I minus 1 phi I minus 1t. So simply this can be written as SIT minus sigma j equal to 1 to I minus 1 Sij phi jt. Okay, now phi it will be equal to git divided by norm of git. So in this way we can find the orthonormal basis function corresponding to all the m signals. If m equal to n, that is number of orthonormal basis function is equal to the number of signals, then we can say that all the signals are linearly independent. If n less than m, then we can say that some signals are linearly dependent. Some signals are linearly dependent. That means for some signals, say GIT will be 0. Okay. So now we will proceed to the problem. So we have 4 signals. So from the 4 signal, we will choose the first signal, say S1t. From S1t, we will find phi 1t. What is step number 1? Step number 1 is phi 1t equal to S1t divided by norm of S1t. So this will be equal to S1t divided by root of E1. What is E1? E1 equal to integral 0 to t S1 square t dt. So this will be equal to, we know that the duration of the signal is only from 0 to t by 3. So this will be equal to integral 0 to t by 3. S1 is 1 square dt. So this will be equal to t by 3. So now phi 1t will be equal to S1t is, we know that the amplitude is 1. So 1 by root of t by 3. So this will be equal to root of 3 by t. Now what is the duration of this orthonormal basis function? The duration of the orthonormal basis function will be equal to the duration of the signal, that is 0 less than or equal to t less than or equal to t by 3 and 0 else. So that is phi 1t. Now step number 2. So For finding phi 2t, we will choose the second signal s2t. So from the second signal s2t, we will define the intermediate function g2t. Now, what is g2t? G2t is remove all the components corresponding to the first axis, that is G2t equal to S2t minus projection of the signal S2t on phi 1t axis, that is S21 phi 1t. Now we need to find S21. We know S21 is integral 0 to t S2t phi 1t dt. So we know that S2t ranges from 0 to 2t by 3, but phi 1t ranges from 0 to t by 3 only. So we need to consider only that duration, that is 0 to t by 3. S2t is 1. 1 into phi 1t is root of t 3 by t dt. So this will be equal to root of 3 by t into t and applying the limit 0 to t by 3, that is t by 3. So this will be equal to root of t by 3. So S21 is a constant, which is a constant. Okay. Now G2t equal to, we know that S2t ranges from 0 to 2t by 3, right? So I will write it as but phi 1t ranges from 0 to t by 3 only. So I will write in two separate intervals. So I will write it as say S2t minus S21 phi 1t from 0 less than or equal to t less than or equal to t by 3. Again S2t minus S21 phi 1t from t by 3 less than or equal to t less than or equal to 2t by 3. Now we will, so G2t can be written as, what is S2t? S2t is 1. 1 minus S21 is root of t by 3 into phi 1t is root of 3 by t. Root of 3 by t. So cancel, it will cancel for 0 less than or equal to t less than or equal to t by 3. And for next interval from t by 3 to 2t by 3, what is S2t? S2t is 1 minus S21, we know that S21 is root of t by 3, but phi 1t is 0, right? That is root of t by 3 into 0 for t by 3 less than or equal to t less than or equal to 2t by 3. So solving, we will get it as 0 for 0 less than or equal to t less than or equal to t by 3. This will cancel, 1 minus 1. Then 1 for t by 3 less than or equal to t less than or equal to 2t by 3. Now, what is norm of G2t? Norm of G2t is root of E2 minus S21 square. So this will be equal to root of E2. What is E2? Integral 0 to t S2 square t dt. We know that S2 ranges from 0 to 2t by 3. So this will be equal to 0 to 2t by 3. S2 square is 1 dt. So this will be equal to, applying the limit, we will get it as 2t by 3. Now, so we have E2 is 2t by 3 minus, what is S21? S21 is root of t by 3. So S21 square is t by 3. So this will be equal to root of t by 3. Now, phi 2t equal to G2t divided by norm of G2t. So this will be equal to 1 divided by root of t by 3. Now what is the range? Range is from 0 to t by 3, phi 2t is absent. Phi 2t is present only in the range of t by 3 to 2t by 3. So I will write it as phi 2t equal to root of 3 by t in the range of t by 3 less than or equal to t less than or equal to 2t by 3. So far we found phi 1t and phi 2t. Now we need to find phi 3t. So for finding phi 3t, we will choose the signal S3t. So from S3t, we need to remove all the components corresponding to phi 1t and phi 2t. That is, we need to find the intermediate function G3t. In the G3t is orthogonal to both the phi 1t and phi 2t. So how will you find G3t? G3t will be equal to S3t minus S31 phi 1t minus S32 phi 2t. Okay, I will write the equations corresponding to phi 1t and phi 2t here. So phi 1t equal to root of 3 by t for 0 less than or equal to t less than or equal to t by 3, and phi 2t equal to root of 3 by t for, I will write like this, 0 for 0 less than or equal to t less than or equal to t by 3, and the root of 3 by t for t by 3 less than or equal to t less than or equal to 2t by 3. Okay, so for finding G3t, we need to find S31. What is S31? S31 is the projection of S3t on phi 1t. So we know that S3t ranges from t by 3 to t, but phi 1t ranges from 0 to t by 3. So we can say that S3t has no component in the range of 0 to t by 3. So I will write it as S31 is, that is S31 will be 0. Okay, now S32 will be S32 equal to projection of S3t on second axis, that is phi 2t, that is integral 0 to t S3t phi 2t dt. So we know that S3t ranges from t by 3 to t, and phi 2t ranges from t by 3 to 2t by 3. So I need to consider only t by 3 to 2t by 3. S3t is 1, phi 2t is root of 3 by t dt. So this will be equal to, so root of 3 by t into t, applying the limit t by 3 to t by 3. So 2t by 3 minus t by 3 is t by 3. So this will be equal to root 3 by t into t by 3. So which will be equal to root of t by 3. So which is a constant. So S32 will be equal to root of t by 3. Now we are ready to find the intermediate function G3t. G3t will be equal to, so S3t minus S31 phi 1t minus S32 phi 2t. I will divide into 3 intervals, 0 to t by 3, then t by 3 to 2t by 3, then 2t by 3 to t. 0 less than or equal to t less than or equal to t by 3. Again S3t minus S31 phi 1t minus S32 phi 2t from t by 3 less than or equal to t less than or equal to 2t by 3. Again S3t minus S31 phi 1t minus S32 phi 2t from 2t by 3 less than or equal to t less than or equal to t. So we know that S31 is already 0 because S31 is projection of S3t on phi 1t, right? S3t on phi 1t, because phi 1t ranges from 0 to t by 3 only, and S3t starts from t by 3 to and ends in t. So there is no component of S3t falling in the range of 0 to t by 3. So I will say that this will be 0. I can remove these components 0. So I will write it as S3t minus S32 52t for 0 less than or equal to t less than or equal to t by 3. Then S3t minus S3252t from t by 3 less than or equal to t less than or equal to 2t by 3. Then S3t minus S3252t from 2t by 3 less than or equal to t less than or equal to t. Okay. So this will be equal to S3t is 1. 1 minus S32. What is S32? S32 is root of t by 3. 5 to t, 5, we know that 5 to t ranges from t by 3 to 2t by 3, right? Okay, so S32 is root of t by 3 into 5 to t is root of 3 by t. So this will cancel. For 0. So, but we know that as 5 to t ranges from t by 3 to 2t by 3 only. So, there is no component of 5 to t in the range of 0 to t by 3. So, I will say that this will be 0. This will be 0. So, only component remaining will be t by 3 less than or equal to so t by 3 less than or equal to t less than or equal to 2t by 3. So this will cancel again from 2t by 3 to t, from 2t by 3 to t. So S3t is present, so that is 1 minus. Now what is S32? S32 is a constant, right? So that is root of t by 3 into. What about 5 to t? 5 to t, we know that 5 to t present only from t by 3 to 2t by 3, right? So there is no component of 5 to t in the range of 2t by 3 to t. So this will be 0. That is 2t by 3 less than or equal to t less than or equal to capital T. So this will be equal to 1 minus 1 is 0 in the range of t by 3 less than or equal to t less than or equal to 2t by 3, and 1 minus 0, that is 1 for 2t by 3 less than or equal to t less than or equal to capital T. Now what about norm of G3t? Norm of G3t will be equal to E3 minus S31 square minus S32 square. So this will be equal to, now what is E3? E3 will be equal to integral 0 to t, but we know that S3t ranges from t by 3 to t. So from t by 3 to t, 1 into dt. So this will be equal to 2t by 3. So we can write it as root of 2t by 3 minus S31 is 0. 0 minus S32 square is, S32 is root of t by 3. So t by 3. So this will be equal to root of t by 3. So 5 3t equal to G2t divided by norm of G3t divided by norm of G3t. So this will be equal to, so we know that G3t is 1. G3t is present only in the range of 2t by 3 to t, right? So I will write it as 0 for 0 less than or equal to t less than or equal to t by 3. Again 0 for t by 3 less than or equal to t less than or equal to 2t by 3. Again 1 divided by norm of G3t is root of t by 3 in the range of 2t by 3 less than or equal to t less than or equal to t. So 5 3t is calculated as 3 by root of 3 by t in the range of 2t by 3 less than or equal to t less than or equal to capital T. Similarly, we can find step number 4. That is, similarly we can find 540. How will you find 540? For finding 540, you need to choose S40. And from S40, you need to find the intermediate function G40. And one more twist here is, we can write S40 as a linear combination of these two signals, S1t and S3t, right? That is, S4t can be written as S1t plus S3t. So we can see that the fourth signal can be written as a linear combination of first signal and third signal. So as I said earlier, if the signal is dependent, then the intermediate function definitely G4t should be 0. So we can try to prove that. Now what is G4t? G4t equal to S4t minus S4151t minus S4252t minus S4353t. Okay. So what is S41? S41 is integral. We know that 51t ranges from 0 to t by 3 only. So that is 0 to t by 3 S4t into 51t. So this will be equal to 0 to t by 3, 1 into root of 3 by t dt. So this will be equal to root of t by 3. Now S42 is integral 0 to, so for S40 we know that S40 ranges from 0 to t, so that is present, no problem. But 5 to t ranges from t by 3 to 2t by 3 only. So I will write it as t by 3 to 2t by 3. S4t is 1 into 5 to t is root of 3 by t dt. So this will be equal to root of 3 by t into t by 3. So this will be again equal to t by root of t by 3. Now S43 equal to, we know that S53t ranges from 2t by 3 to t. So integral 2t by 3 to t 1 into S4t into 53t, that is root of 3 by t. So this will be equal to again root 3 by t into t by 3. You will get it as root of t by 3. Okay. We have G4t equal to, I am rewriting S4t minus S4151t minus S4252t minus S4353t. Okay. So I am again here also I am dividing it into 3 intervals, that is from 0 less than or equal to t less than or equal to t by 3. We know that 5 is absent and 5 is absent. Only component present is 5 So this will be equal to S4t minus S41 minus 0. From t by 3 less than or equal to t less than or equal to 2t by 3, we know that the component present is 5 is absent, only 5 is present, right? So I will write it as S4t minus S4252t, again minus 0. Now from 2t by 3 less than or equal to t less than or equal to t, only 5 is present, 5 and 5 are absent. So this will be equal to S4t minus S4353. So see, S4t is 1 minus S41 is root of t by 3 into 5 is root of 3 by t. So that will cancel. Again next step is S4t is 1 minus root of S42 is also root of t by 3 into 5 t is root of 3 by t. Now S4t is again 1 minus S43 is again root of t by 3, again root of t by 3 into root of 3 by t by 3, t by 3 then 3 by t. Okay. So 0 less than or equal to t less than or equal to t by 3, t by 3 less than or equal to t less than or equal to 2t by 3, when 2t by 3 less than or equal to t less than or equal to t. See, this will be 0. So we found that G4t is, as our intuition, G4t is 0. So as I said earlier, the intermediate function will be present only if the signals are linearly independent. Here S4t is written as a linear combination of first and third signal. So G4t will be absent. So now we can plot our orthonormal basis function phi1t, phi2t and phi3t. So phi1t is plotted as root of 3 by t from 0 to t by 3. This is phi1t. Now phi2t is again root of 3 by t from t by 3 to 2t by 3. From 2t by 3 to t, root of 3 by 2. This is t by 3. So this is a plot of phi3t, this is phi2t. Please like the video and subscribe the channel also. So please do a homework problem. So you have given two signals S1t and S2t. S1t have amplitude A with the duration 0 to t, and S2t have amplitude 2A with the duration 0 to t by 2. Applying Gram-Schmidt orthogonalization procedure, find the orthonormal basis function phi1t and phi2t. Also plot phi1t and phi2t. Thank you.